Hello dear friends, welcome back to SJV Tech class. This is Prabhavati Kundargi. So today in this video I am going to tell you what is Solo's first theorem and how to solve the given example, guys. So this is the most important topics in your CSI NET as well SETS exams. Shall we begin? If G be a finite group and P raised to n divides order of G, then G has subgroup of order P to the power n. So what it means? So just look at here. G should be what? So G, if the given group G is a finite group. So what is this finite? So finite group means what? When we said whether the given group is finite or not, means if the given group G has a finite number of elements or the countable numbers are present in the given group G, then we can say that group is what? So that is a finite group. If the given group G has a uncountable number of elements, so that is what? So that is nothing but a infinite group, guys. Okay, and so here what's our G? If the given G is a finite group and if P to the power n divides order of G. Okay, order of G means what? So order of G, which is nothing but what? Cardinality of G. So what is that cardinality of G? So that cardinality means what? So that is nothing but the total number of elements present in the set G. Okay, and what is this P and what is this n? Means this P should be a prime number. Okay, so this P is what? So this should be a prime number, and this n is n, which is n belongs to Z. Z means what? Integer. Got it? So then G has subgroup of order P to the power n. Okay, so let us see an example. First one is the given order of G is equal to what? 100. Of course this is a finite group. Why it is finite? Because the total number of elements present in this group is what? So these are 100. So first, in the first step, what we have to do means first we have to write the given order of G in the form of product of prime numbers. Here 100 can be written in the form of 25 into 4. Okay, 25 into 4, but here 25 and this 25 and this 4 is what? So these are not a prime number, but the condition is what? First we have to express this order of G in the form of prime number. So 25 can be written in the form of 5 square and this 4 can be written in the form of 2 square. Okay, so that's what I have written here, 5 square into 2 square. If you didn't get how to write it directly, so you can use this prime factorization method also. Okay, so what is this prime factorization method? Means just take the number, whatever it is, it may be, so just divide that number by taking only prime numbers. Got it? So here my prime number is what? So that my least prime number is, that is 2. So I start from 2. 2 times of 50 gives me 100 and 2 times of 25 gives me 50 and 3. So the next prime number is 3, but 3 does not divide 25. That's why I move from next prime number. So what is my next prime number? So that is a 5. 5 times of 5 gives me 25 as well. 5 times of 1 gives me 5, guys. Okay, so 100 can be written in the form of 2 times of 2 and 5 times of 2. Okay, got it? So so this is what I have written here. So after writing this first step, what we have to do means just check this condition. Okay, P to the power P to the power n divides the order of G. The only prime divisors of 100 are, you have to take the only prime divisors. Here 5 and 2 are the only prime divisors, so that's why I take a 2 and 3. You can ask me, 1 is also divides 100, but 1 is not a prime number. 1 is what? So this is neither prime nor composite, guys. Okay, so that's why we can't take 1 as a prime number here. Only the prime divisors are what? 2 and 3. Got it? So next, sorry, this is not a 3, so this is a 5. Yes, I'm really sorry for this thing. The only prime divisors are what? 2 and 5. So next, just check it. 2 to the power 1 divides 100, of course. So that's why we can say that G has a subgroup. G has a subgroup of order 2 to the power 1. 2 to the power 1 means what? Which is nothing but 2. And 2 square is also divides 100. Therefore, we can say that G has a subgroup of 2 to the power 2, which is nothing but what? 4. And next, you can take 2 to the power 3, but we can't take. Why? Because a does not divide 100. So what is there in our given definition? We have to take the only numbers which one divides our order of G. Got it? So what is our next prime number? So that is a 5. 5 divides 100. Therefore we can say that G has a subgroup of order 5. So next come to 5 square. So 5 square divides 100, of course. So therefore we can also say that G has a subgroup of order 5 square, which is nothing but what? 25, guys. So this is most important, guys. So now let us see how the question may come in our examination. Okay. So this is our what? So this is my second example. If order of G is equal to 24, then find possible orders of subgroups. Just look at here. Find possible orders of subgroups. So this type of question will come to us, okay, in our examination. So what is our first step? First we have to write the order of G here. So that is nothing but 24. And what is the second step? In the second step we have to write this given number in the form of product of prime numbers. Okay, 24 can be written as 3 into 2 to the power 3. So here this 3 and 2 are prime numbers. Got it? Subgroup of order 1 and 24 are always possible. Subgroup of order 1 and 24 are always possible. Why it is? Why? Because so this 1 and 24, these are what? So these are the improper divisors of the 24. Got it? 1 and 24 are what? So these 1 and 24 are the improper divisors. So what is that improper? Means the divisors 1 and itself is called as a what? Improper divisors of the group or set also. Got it? So and what is that proper? Other than this 1 and itself, so whatever it may be, the divisors will come, no? So those all are what? So those all are what? Proper divisors. So next one is what? So now let us see which order we will get on where. So 2 to the power 1 divides order of G. So therefore we can say that G has a subgroup of order 2, and 2 to the power 2 divides 24. Right, so then G has a subgroup of order 2 to the power 2, which is nothing but what? 4. And 2 to the power 3 divides order of G. So we can say that so this our given G has a subgroup of order 2 to the power 3, that is nothing but what? 8. And last, we can't take here 2 to the power 4. Why? Because 2 to the power 4 gives me 16, but 16 doesn't divide 24, right? So that's why we can't take next numbers. So now we'll move from the next prime number. So what is that? So that is nothing but what? 3. 3 divides order of G. So then G has subgroup of order 3 to the power 1, which gives you 3. Okay, so finally we can give the conclusion like that. So what they have asked to us, they asked for finding the possible orders of the subgroup of order 24. And what are those four possible orders of the subgroup of order 24 is what? 1, 2, 4, 8, 3, 24. So these all are what? So these all are the possible orders. Got it? So guys, you can so this is a very most important thing. So this is just half. Okay, so in the next video another half I'll be explaining another half. Okay, so here I have given you 2 homework problems. The very first one is order of G is equal to 60, and the second one is order of G is equal to 128. Just solve this question and send the photocopies to this. So this is my number. So this is our WhatsApp number. And if you want to join our WhatsApp group also, you can just send me. Otherwise, the link of our WhatsApp group is there in our description box, guys. You can join directly. I hope this video helps to you all. If you get any doubts or any queries, you can comment. You can comment me in my comment section. Otherwise, you can send a message into my WhatsApp also. Okay, I hope you like the video. If you like the video, give a big thumbs up and don't forget to share with your friends as well with your colleagues too. And see you in our next video. Until then, take care. Bye bye.